And I thought now we'll go on to part 3 and look at a number of cases where blockchains have gone wrong and why they went wrong. And the first one I'm going to look at is what I've titled bad password security. So this one's a Bitcoin one, and it goes back to about 2013 or so, where someone had the great idea that remembering Bitcoin passwords is very difficult because they are 256-bit numbers. That's a lot of ones and zeros to memorize. But they noticed that this computer function that was used in Bitcoin, something called the hash, is a function that takes as its input any kind of data and it outputs a 256-bit number. And that 256-bit number behaves like a random number. You can't predict in advance what it's going to be, but if you put the same data in, you get the same 256-bit number out. And similarly, it's irreversible. If someone gives you a 256-bit number, it's impossible to come up with some kind of data that you would need to put into this function in order to get that number. So they thought, this is great. You can take a simple, easy to remember passphrase, put it into the hash function, get a 256-bit number out, and that is conveniently what a Bitcoin private key is. And they call this a brain wallet, and it means you can carry your password around in your head. It turns out that this is a very bad thing to do because people are not very good at coming up with truly random passphrases. And so instead of your password being a random number between 0 and 2 to the power of 256, which is huge and therefore can never be guessed, you've shrunk the set of possible passphrases down to something that can actually be searched with a computer. And in computing terms, the entropy has been massively reduced. It becomes very predictable. And what happened was some people picked really bad passphrases, and I have some examples here. One, someone picked a passphrase, Bitcoin is awesome. And that guessed, and 500 Bitcoins got drained from their Bitcoin address. Another one, which when I first read it, I thought, well, how did anybody ever guess that? It was the phrase, you don't win friends with salad. And that one actually doesn't have a terrible ending. The account had 157 Bitcoins in it. Only 3 were taken, and they were returned by the person who took them. They just wanted to teach a lesson to the person who used this passphrase. And I found out later that the phrase, you don't win friends with salad, actually comes from a Simpsons episode. So that's why, although on the surface of it, it sounds really, really random, it's not random. Someone just had to take the scripts from The Simpsons and run them through a password cracker. And that allowed them to find the private key and steal the Bitcoins. We see this similar problem of bad password security in non-blockchain cases as well. The most famous recent one is the SolarWinds hack, where a company that made security software that was being relied on by Microsoft and the Pentagon and all sorts of government agencies got hacked. And it turns out that someone had created a backdoor password for them to test the system, and they'd used the password the company's called SolarWinds. So it doesn't take much password cracking to come up with that one as an independent hacker. So that's an example of a Bitcoin failure based on bad password security. And the next ones I'm going to look at are to do with Ethereum and smart contracts. And maybe it's worth having a brief chat about what smart contracts are. People say that they're not smart and they're contracts. Software developers say they are just small programs or pieces of code that you deploy to a smart contract blockchain such as Ethereum, and the nodes then run them as and when circumstances dictate it. So they're little programs sitting on the blockchain, and they can get triggered when people submit transactions to the blockchain that refer to them. One of the really neat things about smart contract blockchain systems is that they allow computer programs to own digital assets the way that Bitcoin allows human beings to own digital assets. So you, on Ethereum, you as a person can own Ether, which is the equivalent to Bitcoin on Ethereum, And I think at the moment it has a market value of about $3,000 per ether. On Ethereum, you can actually transfer that value to a computer program, a smart contract, and then the program will do with those funds as it sees fit according to the code that the developer deployed. So in a sense, that's quite a revolutionary idea. It's as revolutionary as the idea of limited liability companies, which in law have standing as entities or people. So in the blockchain world, smart contracts can act like human beings and that they can own stuff and they can do stuff with the things that they own. The other thing that smart contracts can do is they can instantiate data structures, and those data structures can include things like tokens, such as non-tokens, or other kinds of cryptocurrencies. So very flexible, very interesting things. Also open up the door for all sorts of disasters. The first one I want to look at is something called the Distributed Autonomous Organization, or DAO. And it was a set of smart contracts that you could deposit Ether into, and then it worked like a venture capitalist fund, where the people who put Ether into it could vote on handing that Ether over to projects that they wanted to fund. So it's like a VC firm without a CEO or anybody in charge. It's a democratic funding system. There were a few bugs found that got fixed, and then a really big bug showed up. At the point that the really big bug showed up, about 12 million ethers were deposited, which at the time was worth about $150 million. So you see, we're not talking about small amounts of money. The bug is to do with a code audit failure. Even though the code had been audited many times, the developers missed the fact that there was a technique that allowed people to withdraw more money than they put in. I think a good description of this bug is an ATM bug. If you go to a cash machine and you put your card in and you have money in your bank account, the cash machine checks what your balance is, looks at how much you're asking to withdraw. As long as the amount you're looking to withdraw is less than the balance in your bank account, it lets you withdraw it. Now, imagine an ATM that only checked your balance once and then allowed you to request again and again to withdraw cash. That would allow you to withdraw more cash than you had in your bank account. So let's say 100 in the bank account, you put your card in, you say I withdraw 50, it checks once that you had 100 and says, yeah, here's 50 quid. Imagine if you could key in, yeah, I want to withdraw another 50, another 50, another 50. It doesn't go back each time and check that you have a lower balance. It still assumes that you have the original 100 and just keep feeding out 50 notes. And that's what happened to the DAO. And a hacker managed to drain about 4 million of the ethers. The result of that was that the community went into a bit of a tailspin. They had some huge discussions, and they actually decided to roll back the history of the Ethereum blockchain. Not everybody agreed, and it actually split the blockchain in two, but the majority agreed to roll back Ethereum and pretend that the whole thing hadn't happened. But anyway, there you go. That's what happened with DAO. I'm just keeping an eye on the time here. I think I've got another 10 minutes or so. So I'll move on to the next case, which is the Parity multi-signature wallet fiasco. And this one was a code deployment failure. So the code had been audited. The code was effectively an online smart contract wallet that allowed people to deposit their funds into a wallet account, and then it could only be withdrawn if multiple people signed it. So it works a bit like a company bank account where the CEO and the CFO have to sign off on checks. And companies have these things to stop rogue CEOs from buying Lamborghinis with company funds. Now, the problem with this one was that when the code was deployed, in order to great, they forgot when they deployed the code had something called an owner. There was an initialization function, but when the code was deployed, the first person to run that function got set as the owner of the contract. And then there were a bunch of functions in the contract that only the owner could run. One of those functions, so and this is another thing that they made a mistake on, was it was called a kill function that stopped the program from ever being able to be run again. A random person on the internet who just went by the handle DevOps9, found that the contract hadn't been claimed the ownership, and then ran the kill function. That froze all the funds that were in the wallet. And again, we're talking about hundreds of millions of dollars worth of Ether at the time. This time, there wasn't a rollback, and those funds are still locked, and there is no way they will ever be retrieved. So that's a code deployment failure rather than a bug in the code itself. And I think now I'll just jump onto a third case and skip on. I think the one I want to talk about is non-fungible tokens, because they're quite hot at the moment. And this one I would call an interface failure. There's a standard for called ERC 721. What the standard requires is that your smart contract has the right interface. It needs to have a transfer function. It needs to have a minting function. It needs to have a function that gives you permission to allow other people to transfer a token on your behalf, and so on. So as long as you write some code that has the correct looking interface, then to everybody else, it will look like a non-token contract. You can list it on some of these sites that allow you to trade non-tokens. The issue I want to discuss here is something that is known as sleep minting, which is where you write a non-token smart contract that creates one of these NFTs, but the back-end code isn't what people would expect. You put a backdoor in that allows a specific address to also transfer the token, not just the token owner. It turns out that the NFT websites don't have either the skills or possibly the time or possibly both to review every single contract that is deployed on the Ethereum blockchain. So they just put up a disclaimer that says, we haven't verified this contract. If you do want to engage in trading with this, it is up to you to go and check that it is a genuine ERC 721 token without a backdoor. I guess this is kind of like having a car with a digital key. When you sell the car, you change the digital key so that the new owner is the one who owns it, but you keep a secret backdoor key so that you can go along later and use that key to steal the car back again. The fact is, of course, that the average person cannot go and audit a smart contract code. Even competent Solidity developers, smart contract coders, are not going to find this a trivial thing to engage in. And certainly nobody wants to go and audit smart contract code every time they go and use a smart contract, just in the same way that nobody wants to read all 27 pages of the terms and conditions, click through when they want to use a piece of software. So in practice, people just get on with it. The issue here is that some of these tokens are selling for tens of millions of dollars, and some of these smart contracts are locking up nowadays billions of dollars worth of cryptocurrency. And yet we just happily go ahead and most of the time use these things. So this is the problem I see in the non-marketplaces, is that you have no real guarantee that the token that you are buying can't be secretly removed from your wallet. You would have to order the code, and even I really wouldn't want to take the time to do that. The second problem that we have is that some of the websites misrepresent the information. If you go and look at OpenSea, it claims that the token is minted by the first address that it goes to. And in fact, you can find an article from my LinkedIn account where I show that it's possible to mint a token as though it was made by a famous online artist, when in fact it was made by me. So these are the problems we face when these blockchains are presented to ordinary users through interfaces. You don't know whether or not you can trust the interface. And again, this is a problem we see in the traditional world of software as well. When you go to a website and you think it's a genuine website, but somebody has changed a letter in the domain so it looks like it's an I, but it's an I with an accent on it. And you think you're going to Microsoft, you're going to MI Acute Soft. Your web browsing session is being hijacked in a sense. So those were three cases where things in the blockchain world went wrong. So I think I just want to sum up with a conclusion of, well, what can we take away from this? There's now billions in value locked up in blockchain systems in the form of their cryptocurrencies and in these smart contracts. In fact, we're over $1 trillion now in terms of what some people call market capitalization for blockchains and cryptocurrencies. Because it's decentralized, if your funds are stolen from you, you don't have anybody to turn to in order to ask for the transaction to be undone. The systems are so complicated that the average person or even experts can't really audit the full system. It's too complicated, and sometimes the code isn't even available for you to go and look at. So really, it's the Wild West out there, and we don't even have any sheriffs in town yet. I guess that's the warning. When you're investing or speculating or trading in the blockchain world, you have to remember that it's not the tame, regulated world that we have for traditional finance. It's not gambling, but there are just extra risks that are involved, and you have to keep that in mind. So that's the end of my talk. I hope you found it interesting, and let's open up to questions.
Thank you very much indeed, Keir, and I found it fascinating. We do have a number of questions that have come in, and I had a few observations myself as well. It was interesting when you said about smart contracts. Smart contracts can now have ownership. It made me think of the artificial intelligence that I understand is in Saudi Arabia has residency so that she can be taxed. If we're going to the point where devices and things other than human beings and companies that we have a tax system for are going to be able to have those properties. Has anyone ever discussed the tax implications around those at all?
I haven't had many conversations about tax. It's a very complicated issue, actually, because you have all the different jurisdictions which have their own rules and regulations and rates and stuff like that. I mean, I think the thing to consider there is that we've got long-standing non-person entities that can be taxed, namely companies. Companies pay company tax. The governments audit those companies to ensure that they're complying. And of course, the companies go to great lengths to ensure that they're in the right jurisdiction in order to reduce their tax bill as much as possible. And in America, they even enter into negotiation with various states to get good deals to locate a particular place. I think it's going to be an interesting one when it comes to a decentralized smart contract. If that smart contract is holding cryptocurrency that has value or worth, and it starts making profit from it, yeah, who does a government tax? Glad I'm not the one who has to solve that problem. In Finland, it wouldn't be an issue because cryptocurrencies don't become a taxable event until they are converted into fiat. And of course, if you have a smart contract sitting on a blockchain and it is converting Ether to DAI and DAI to BAT and then BAT back to Ether and making a profit, it's not off-ramping it to euros or dollars. However, I can see a future where, in fact, there's a Dutch family who I believe for years now have been, as an experiment, living solely off Bitcoin. I imagine at some point there are going to be more people who are conducting that kind of experiment. At that point, there are going to be governments that say, hang on a minute, just because you're not converting to our taxable currency doesn't mean you should get away with no taxes. I think that regulators and lawyers are going to have a field day working out exactly how they're going to be going about it. A well-constructed, decentralized system may just be impossible to tax. There may not be an entity that you can go to and say, give me that. But I suppose at some point, somebody's going to want to get their hands on the wealth.
I would have thought so, yes. As I say, we have a number of questions. And Jonathan, are you happy to read out your question and ask Keir directly yourself? Do you want to unmute yourself and ask the question? And wonderful.
We will do that. Keir, it's good to hear from you. And just part about exchanges. You mentioned earlier on that we're looking at a substitution from, say, the world of banking into what crypto offers. But aren't exchanges the new gatekeepers? Because they control processing, they control transactions, they control the entry and exit of fiat money, currency, and they charge fees for the work performed. In the case of Bitcoin, when we hit that hard limit, we're going to see a sort of free for all when it comes to what fees that they'll need to charge, because there won't be, miners won't be accruing compensation from their mining activities. What's your view on exchanges being those gatekeepers?
Yeah, I mean, you're absolutely right that if you want to go from fiat to crypto or crypto to fiat, you have to go through an exchange, and they are indeed charging fees. I would say that's to be expected, given that you are interfacing with the traditional fiat currency world. That's how that one functions. Once you're in the cryptocurrency world, then you no longer need to use centralized exchanges. Now there are decentralized exchanges, and they are kind of in a race to the bottom as to which one charges the least fees in order to run the service. But yeah, I agree, you're right. When it comes to transitioning between the cryptocurrency world or the token world and the traditional finance world, there are going to be gatekeepers, and I don't really see how there cannot be, because traditional currency requires a custodian. It requires somebody to be managing it, or some entity or company. I hope that answers your question to some extent.
Thanks. I think it's just interesting to reflect on the fact that in effect what we've done is translated the role of a bank or a banker into the role of an exchange, and equated the same degree of trust between the two, when in the current banking it's heavily regulated, and in the exchange world it's not. So I just want to question the thinking around translation.
Yeah, it's true. Actually, the regulations are coming for the exchanges. The ATF passed regulations or recommendations in 2019, and slowly making their way into law, that virtual asset service providers such as exchanges now have to do AML and KYC in the way that traditional financial institutions have to. And they're struggling with that, of course. But of course, those regulations are in place in order to stop money laundering and terrorism funding and stuff like that. It's not about keeping you and me as personal customers particularly safe or well catered for, just for society in general, I suppose. I guess the one thing with exchanges is that at least you can make it a one-time trip, that you have one transaction with an exchange and then you're in the cryptocurrency world. And as long as you stay there, then you don't have to deal with them again. Whereas in the traditional financial world, you're kind of, I suppose, unless you got all your life savings in one go and converted them to cash, you have to deal with the traditional finance gatekeepers again and again for each transaction. I don't know what we can make of that, really. But you can turn it to one transaction rather than one every time you transact.
Thank you very much. And then Craig, would you like to ask your question yourself?
Sure. Thank you for hosting and being here. NFTs on the ERC-21 contract, it just points to the URI, which is just like is a link. How do we ensure that the image, the video, the piece of content that we're purchasing is forever available and hosted?
Well, good point. If it's just on a website, then of course we can't. Then it requires that website to be hosted, and if the person hosting the website with the image decides not to pay their domain fees and web hosting fees anymore, and then somebody else buys the domain and decides to put something else on that site at that URI, you've now got a token pointing to a totally different image. Their only feasible solution at the moment to this persistence problem that I've seen to date is the interplanetary file system, where you take your image, your JPEG, and when you upload it to an IPFS server, in part of the process is that the file name is changed to a hash, and the hash is generated from the content of the JPEG. And that means that that file names will stay consistent throughout time. This has a couple of ramifications. So one is that the URI to that particular JPEG will always be roughly the same. There can be a different precursor because you can have different IPFS servers that you would go and approach. But the end bit for the file name indicates where that file is and allows any IPFS file server to find it. And if for some reason all the IPFS file servers decide to stop hosting that particular JPEG, if at some point in the future someone uploads the same JPEG again, it ends up with exactly the same IPFS file name. And actually, this is one of the things that suggests to me that the IPFS needs a slight improvement, in that the URI for an IPFS file starts with the IPFS file server and then with the IPFS file name. And really, it shouldn't matter which IPFS file server you're using. So that first bit isn't important. That should actually be a setting in your web browser where you say, I like to use IPFS.io, or I like to use Pinata or something like that. And you should just be able to say, I want to find this file name. And then it retrieves for you. Therefore, the NTFS should in its URI just have the IPFS file name. And that would give you, as long as the IPFS system continues to run, that would give you persistence for that JPEG. But I happen to think that the URI part of NTFS it's a hacky attempt to link the on-chain token to some off-chain system. And I think there's still a lot of work that needs to be done there. And don't even get started on trying to link it to things in the real world, because then you end a whole bunch of extra problems.
Something an Oracle can take care of.
Maybe.
Yeah. Thank you.
And when you're talking about the difficulties that we're facing, you've mentioned there are pitfalls have come up because the testing hasn't been done properly, the auditing wasn't done correctly, there were flaws in the deployment, there potentially could be backdoors, and there's the subject of misrepresentation. Are there other industries that we can look to see how these areas might have been tackled to be able to bring in best practices to our industry? And
well, I think the problem we have is that the sort of traditional non-blockchain software industry is really broken. I follow a few people on LinkedIn who post security breaches, and you can find one a day. The cloud leaks like a sieve. The architecture of our computer systems started off on a basis of trust. When you look at how things like Unix were set up, it was kind of assumed that it was going to be running in a university where everyone was nice to each other. And most of the security solutions are kind of bolted on. And we've now got decades of infrastructure, and then we're trying to patch it by sticking things on the side and in front of it and behind it, rather than the core itself being strong. Then there is that second thing, that for business, ultimately it's about speed rather than reliability, because that's the way, it's the first to market win, or is more likely to win. The one that spends more money on their marketing budget may beat a better solution. So it's kind of inherent in the system that we've set up. The computing side didn't start from a security basis, and our commercial systems are not based on providing secure and robust software. They're based on building market awareness and market share. And we are too far down the road, I think, to throw it all away and start again. So I think we just kind of have to accept that it's all going to be a bit shoddy. And I think if you talk to people in, for example, the banking system, they'll quite readily tell you that banks are full of legacy systems written in old programming languages, running on old boxes, and they don't dare turn them off, even though they have no idea what they're doing, because they're concerned that if they turn them off, then suddenly some critical infrastructure part will stop working. And who knows what will happen if those boxes one day just give up the ghost. But that's kind of the way it is.
I think we've got time for one more question. Also, for any questions that we haven't had a chance to get to, perhaps you can reach out to Keir and ask him there, and we might be able to put them in a follow-up. So Miguel would like me to read out their question because they're in a noisy background. Assuming that blockchain responds to a new paradigm in terms of decentralization, transparency, governance, what main changes do you think should be made before in the traditional world, governments, companies, sector regulation able to adopt in a general way? I don't know if I read that correctly.
So I guess that question is, how can governments go about adopting blockchain, given that at the moment it's more of a sort of people push, it's individuals pushing projects out. Have I understood that right, Bridget? Or I don't really grasp the gist of the question.
I guess it's asking if we're moving to a paradigm in terms of decentralization, transparency and governance, what do the traditional world like governments need to be able to do to keep up?
Well, governments aren't really built around moving quickly. So, having talked about the software industry and how it's move fast and break things, if I'm being cynical, I'd say a government is all about move slowly and spend lots of money. It's when you look at government IT projects, certainly in the UK, they don't have a marvelous track history in terms of cost efficiency or services provided. But I guess they're getting better over time. I don't really know. Maybe it's just a matter of them having people looking at this. I did some work for the Finnish Ministry of Transport about 2 or 3 years ago. And I found that governments are very good at and happy at sort of doing blue sky thinking funding. And they actually seem to be doing a reasonable job in terms of infrastructure. I certainly wouldn't want to take over their responsibility, but this middle ground, when it's not already established, is a bit difficult for them. And if you look at Geoffrey Moore, Crossing the Chasm, a book about the adoption of software, and there are these sort of categories of early adopters, and then at the other end you have, and I think governments are kind of required to fall into the sector that you don't want your government to be pushing out brand new untested technology when they are overseeing things like our health service or our electricity infrastructure, or our road infrastructure, or stuff like that. Because something as simple as putting a new toll system on a bridge over a river and then messing it up can have a huge impact. Can you imagine if you couldn't get across the Thames at Dartford for 4 or 5 days, what that would do to London? So I guess they're required to be careful. But I think that they all pretty much now are following blockchain fairly intently. There's certainly lots of EU projects and committees and groups who are studying stuff, and there are now lots of funds going out to research projects and stuff. But I wouldn't expect them to jump on things immediately. So do you think that answers the question?
Thank you so much, Keir. We've had our full hour. I would like to ask everyone to show their appreciation for Keir by either taking your videos off or using the reactions that we've got. Also, I know that we've already got one of your copies of your book sold, but if you like what we're talking about, and one of the things that I really admire about Keir is that he has the ability to explain things in a language that a non-technical person can understand, and also explain to someone else, as well as being able to deep dive down into the difficulties, the technical aspects. So it's an absolute honor to have you with us. I will be sending a recording out to everyone, and if you'd like to know more about the Bigger Pie, then please do let me know. Thank you very much, everyone.
Thank you very much, Bridget, for having me.